Okay, so this problem is 128 and involves making a substitution. So before we look at this, make sure you have looked at either the STEM online, but in this case, New Lake here, page 189. And this is interesting. New Lake here says is optional. No, put a line through that. This is definitely things you need to work on. And because you probably do 2 or 3 of these if you're going for the merit of excellence in the external integration paper. Just do look at the examples here, and the key thing is you'll see this sort of working over here. This interesting arranging the du by dx expression. Well, what's differentiation going to do with this? You'll soon realize that. So, and this technique applies to a whole range of problems, like this one here, something to the power of big number 5, or unusual cos expressions here. You can sort of see. What other examples? Quotient and so forth. Okay, so it's very, very varied, but sometimes it works well, sometimes there are other methods. So let's get into it. So the key thing here is okay, this here is given to you in New Lake. You're not going to be given this in the actual assessment, so go figure. But what it says is using u equals x plus 2. So what you're going to do is you're going to write let u equal that, and then straight away underneath it, du by dx. And obviously that's 1. And then you're going to basically break up this expression here. Just treat it like a fraction. Technically it's not a fraction, but let's treat it like one. And that's going to pop up here. So in other words, du equals dx. And then you're going to go over here and you're going to make your substitution. Okay, so hello, you got the 24, and basically the x plus 2 has been replaced with u to the minus 4, and this is where it gets interesting. Dx has been replaced with du, and there we have it. So what you've done is basically that is very hard to integrate, and now this is more user-friendly. So same process, any constant, put it outside, for example there, do the integration. So add on 1, that becomes minus 3, and then divided by that, and plus c, and 24 divided by negative 3 is negative 8, and I've dropped that down because that's minus 3. What is u? U is the substitution here, and there is your answer. As a proof, you could do a chain rule here, and by differentiating this as a chain rule, you'll get this expression here. Anyway, let's go to something a bit more challenging. This is a bit annoying, the fact that New Lake are suggesting you do this bit here. Pretend that wasn't there. Obviously, inside the fraction here, we're seeing 4x plus 2 to the power of negative a half dx. And so that's the bit we're going to do our substitution. So let u equal x plus 2, du by dx equals 1. So du can be put equal to dx. And now do your substitution. In fact, I'll do, basically the 4 can come out. And let's bring that up like I've done there. And there we have it there. So that there is now a lot more straightforward to integrate than, say, this. And this is integrating with respect to the variable u. This thing here was integrating with respect to the variable x. Okay, so same process. What do? You add on 1 to that. That becomes half. Then you divide that by the half plus c. That pops up there, gives you 8. And what's u? U is this thing here. And either one of those answers, well, this is the better one because you replaced u. Or you could have had 8x plus 2 to the power of a half plus c. So there are 2 examples involving substitution rule. Which way? This way.